Today we are on partial variation. Partial variation, and we are going to use SSCE 1989 past question as our first example. As our very first example. For partial variation, we will get two constants. Two constants. Therefore, if we are asked to find the two constants, we will solve it simultaneously to get them. It says that a variable y, so we have a variable y is partly a constant. That means we have to introduce our first constant. Let's call it k1. And partly, that means there is another one, constant, that we have to introduce. Let's call it k2. Varies as the square of x. So the second constant will multiply the square of x. Therefore, we will get k2x squared. This will be the expression. Now, to get our first equation, it is saying that x is equal to 2. Now, we have x equal to 2, y equal to 6. If we put in x equal to 2 and y equal to 6, we will get our first equation. So we have y 6 k1 plus k2. Then this time around our s is what? 2. So 2, but remember it's what? Squared. 6 k1. 2 squared will give you what? 4. 4 times k2 will give you what? 4k2. This will be my first one equation for the first x and y. Now let's move on to the second x and y. We have x to be 3 and y to be 10. Let's put these ones into the expression there. This time around our y is 10. So we have 10 equal to, we have k1 plus k2. Then this time around our s is what? 3. So 3y squared. 3 squared. We have this, therefore we have to what? Simplify it. Simplify this one. We have 10 equal to k1 plus 3 squared, 9. 9 times k2, we have 9 k2. This will be my equation 2. Since we have two equations, we have to solve it simultaneously. Either any of the simultaneous method that we can apply to solve, you can use that. But I am going to use what? Elimination method, because we have here coefficient to be 1, coefficient to be 1. Therefore, it is very much what? Simple. Then I will say equation 2 minus equation 1. For equation 2, we have 10. Then minus. The equation 1 is what? 6. Then equal to equation 2, we have k1. Equation 1 minus equation 1, we have also k1. Then equation 2, there is plus. Then we have 9 minus 9 k2 minus 4k2. 10 minus 6 will give us what? 4. k1 minus k1, it goes 0. So there's no need for you to write. Then we have 9 k2 minus 4. 4k2, which will give us what? 5k2. Since we have only k2 there, we can find what? The value of k2. Making k2 the subject, we have to do what? Divide both sides by 5. Dividing both sides by 5, we have 5k2. Then 5 will divide 5. Therefore, we can conclude that k2 is equal to 4 out of 5. Let's move on to find k1 value. So we put we have two equations, equation 1 and equation 2. Any of them will give you what? The answer. Any of them will give you the answer. So I will put it into equation 1. And our equation 1 is 6 k1 4 k2. This is our equation 1. And our k2 is 4 out of what? 5. So we have 6 is equal to k1 4 k2 4 out of what? 5. Let's simplify this one. Then we have 6 k1. When we multiply, we get what? 16 out of 5. Grouping of like terms, we group by sending the 16 out of 5 to the other side. Then it becomes what? Negative. Then we have 16 out of 5 equal to what? k1. We can multiply this by this, then we get 30. 30 minus 16, we get what? 14. So 14 out of what? 5. When we solve, then k1. Therefore, I can conclude that k1 is equal to 14 out of 5. 14 out of 5. Now, the question said that we should find the equation connecting x and y. We should find the equation connecting x and y. The main relation is y equal to k1, then k2xy squared. Now, we know our k1. Our k1 is 14 out of 5. So we have 14 out of 5 plus, what's our k2? Our k2 is 4 out of 5. So we have 4 out of 5x. So this becomes the equation connecting the x and the y. Now let's move on to the I part. The I part also states, find the value of x when y is equal to 5. When y is equal to 5. For y is equal to 5, x we don't know. That's what we are going to find. So simple. We put the value of y into our equation. We put the value of y into the equation, then we find what? X value. So we can say this y is now at 5. Then we have 14 out of 5 plus 4 out of 5. Then xy squared. Here, we can find the LCM, or simple, we multiply through by 5. So when we multiply through by 5, 5 times 5, 25. When 5 multiply this, it will cancel the 5. This 5 will go away. Then left with what? 14. When 5 multiply this 1, 2, the 5 will go away. Left with what? 4. Then what? xy squared. we do what? We group what? Like terms. You have 25, then 14 we move here. We have negative 14 equal to x squared. When we subtract 14 from this, we get what? 11. Then 11 equal to x squared. 11 equal to x squared. We want x, therefore we divide both sides by 4. When we divide both sides by 4, we get x squared equal to 11 out of what? 4. But we also want what? X. So we take square root of what? Both sides. When we take square root of both sides, it becomes plus or minus square root of 11 out of 4. This means that the answer can be positive or negative. The answer can be positive or negative. Then, finally, 11 root of 11 the answer is 1.658 or negative 1.658. These are the answers for the value of what? X. If you are asked to choose the positive, you will choose this one. And if you are also asked to choose the negative, you will also choose this one. That's for the I part. For the I. Find the value of y when x is equal to 4. The value of y when x is equal to 4. I. It is saying that x is equal to 4 and for y we don't know. So putting the value of x into the connection, we will have y equal to, then we have 14 on 5 plus 4 on 5. This time around our x is what? 4. So we have 4 squared. This is we have 14 of 5. Then this one square will give us 16. 16 times 4, 64. Then out of what? 5. When we solve this, give us 78 out of what? 5. When we solve this, it give us what? 78 out of 5. So we can also decide to change it to what? Mixed fraction. Changing this one to mixed fraction, it will give us 53. Then also, let's change it to decimal basis. It will also be 15.6 as our answer. The next example, under partial variation, state that the resistance R, so we have R to the motion of the car is parallel. So we have parallel. That means we have to introduce what? Our constants. Let's say our constant, let's make our constant F. And parallel varies. Another constant, let's make our constant G as square of speed V. So the speed given here is V. So we have V then square. and G are the constants. When the car is moving at 30 kilometers per hour, that means we have our speed. Our V becomes 30, and the resistance is 630 Newton. That means we have our R to be 630. We are going to use this one to form our first what? Equation. We have 60, 360 equal to F plus G, and the V is what? 30. Then all what? Square. Let's simplify this one. We have 630 equal to F. Then 30 square will give us what? 900. So 900 what? G. This becomes what? Our equation 1. And it continues to state that and at 50 kilometers per hour, this time around our speed is 50. And our resistance is 950 Newton. So we have what? 950. Let's put these ones also into our expression, which is the R becomes 950 equal to, then we have our F plus, then we have our G. Then our V is now 50. So 50 square. Breaking it down, we have 950 F plus 50 square will give us 2500. Then what? G. This one becomes what? Our equation what? 2. We are going to solve the equation 1 and the equation 2 by using elimination method, which becomes much easier because we have F here and we have what? F there. We have to subtract. So we write equation 2 minus equation 1. So for the equation 2, we have 950 minus the equation 1, 63. Equation 2 followed by F. Equation 1 minus F, then plus equation 2. We have 2500 G minus equation 1. What do we have? 900 G. So equation 2 minus equation 1. So this one is equation 2, this one is equation 1. This one is equation 2, this one is equation 1. This one is equation 2, this one is equation 1. So when we subtract this one from that, we get 0, 2, 3. Then F minus F, 0. When we also come here, we subtract, we get 0, 0, and this one we get what? So we have 1600 what? G. 1600 G. We want what? The G. So what do? We divide both sides by what? 1000 what? 600. Divided by this will divide that, and when also we divide this, you will get 1 out of 5, then G. So our G is equal to 1 out of 5. We have to find our F. We have to find our F. So we putting G equal to 1 out of 5 into equation, let's put it in equation 1. And our equation 1 is 630 equal to F plus 900 what? G. But and our G is 1 out of what? 5. So we put 1 out of 5 in there. Times 1 out of what? 5. So from here, what do? We can decide to bring the whole thing to the other side, or we can also decide to divide first. So let's divide. 5 goes here, 5. Then 5 goes here, 180. So we have 630 equal to F plus 180. Let's group like terms. Grouping like terms, we send this one to the other side. We have 630 minus 180, then F. When we subtract 180 from this, we will have 450. So our F is equal to 450. Our I part is saying that we should express R in terms of V. We should express R in terms of V. Our main relation was R equals to F plus G. Our R is known, is there. Then our F, which is a constant, we have to put the number there. What's the number for the F? The value for F? We got what? 450. The G, the constant G, what did we get? We got 1 out of 5. So we have what? 1 out of 5. Then what? V1 squared. So this is the expression for the I part of the question. Let's move on to the I part. The I part, we should find the resistance at 80 kilometers per hour. We should find the resistance at 80 kilometers per hour. Now, for the resistance, we don't know. For the V, it is given in the question, which is what? 80 kilometers per hour. We have to put this value into our expression so that we will get our R. So we can say R is equal to 450 plus 1 out of 5, then 80, which is for the V, or what? Square. Without wasting time, we can point this one, or 450 plus 80 squared, 400, then divided by what? And our answer will be 1730. Our final answer, we have to add what? Newton to it. So we can conclude the resistance at 80 kilometers per hour is 1730 Newton. This is the